Hey, 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 hey. Hey, hey, hey. Da-da-da. Hey. Welcome. Yes, Mr. War here at your service with yet another math video as we, look at the feature animal of the day. Look at that. We have ourselves, my friends, looks like a little hedgehog. I think that is a hedgehog. He's a cute little fella, ain't he? Anyway, I hear they're pretty popular as pets now, are they? Anyway, let's get down to business. That's why we're here. Not to talk about hedgehogs, Mr. War. Let's get focused. Okay, here you can see we have a learning target. I know it's official. I've kind of pushed objective to the side in parentheses, and now I put learning target. But basically, they're the same thing. It's what our goal is here in this video. And it says that we're going to be subtracting decimals using place value strategies, and we're going to relate those strategies to a written method, which, if you recall in the previous video, we have done that. And now, rather than adding, we're subtracting. So let's move down. We also have something called language frames. Okay, language frames are pretty cool. Now, what is a language frame? This is to help us verbalize, say what we're thinking in math. Sometimes it's difficult for us to explain what's happening. And a language frame is a great way to do that. Another way to solve this problem is because As you can see, I got carried away there with my little blanks there. Okay, sorry. Anyways, this problem is similar to blank because of blank, and you get the idea. The pattern that I noticed was something is hidden. What's here? Oh my goodness, look at it's 3 baby hedgehogs. Wow, look at here, almost like in a row. Very funny, Mr. Wara. Yeah. Okay, now what do we have here? Well, we have some hedgehogs that are getting in the way here. Let me do this. Hey, we'll let you sit right there. Get this mathematical practice. Look for and make use of structure. And this is important because this goes along with the Common Core math standards, is understanding the mathematical practices. It says I can see and understand how numbers and spaces are organized and put together as parts and wholes. And as you can see that when you're looking at numbers here, the base 10 structure, what we're going to be looking at today, of course, operations and properties. Look here, we have an area model. Okay, again, seeing how the structure makes up. Look at this. We have the distributive property being used there, and of course, spaces with three-dimensional figures. You kind of get the idea? Yeah. Okay, so let's kind of move on. Oh, I kind of want to take one of these guys with me. Come. Anyway, next page. Let's get down to business, my friends. Mr. Wara, it's time to get focused. Okay, first things first then. It says 5/10 minus 3/10. This looks very, very familiar, like a problem we had earlier, but now it has a subtraction sign. Okay, fair enough. And it does say that the units here are the same. So if the units are the same, right here, you can see that this is really just saying like 5 minus 3 then, right? We have the same unit. And again, we had an example I think I gave in another video, but when you have, the same kind of something, we can subtract them because the unit is the same and tenths are the same as tenths. So this would be pretty simple. I don't think we're going to need our place value chart. It's just going to be 2/10. And it's going to be 2/10 because we have the same unit and it's just 5 minus 3. Almost like whole numbers, right? Okay, here we have 7 ones, 5 thousandths, okay, minus 2 ones and 3 thousandths. Well, it's kind of interesting when you look at that. You say, okay, well, these units are the same, right? And those units are the same. And since we're subtracting 2 ones and 3 thousandths from that number, it'd be important that these two numbers be smaller than these two, or we'd have some problems, wouldn't we? But since we have more ones here than we do here, we could say that that's really just 7 minus 2, which is 5. That would leave us 5 ones. And then, of course, here we have 5 thousandths minus 3 thousandths, which is just 5 minus 3, right? And that's going to equal 2 thousandths. And I'm going to kind of just abbreviate that. Okay, so we end up with an answer of 5 ones, 2 thousandths. We have 3 hundreds, 5 hundredths, minus 3 hundredths. Oh my goodness, could they make this problem any more confusing? Yeah, they probably could. This clearly is a whole number because we're talking about 900. Okay, very different than hundredths, which of course is a very, very small number in relative size to a whole number, I should say. Let's go ahead and use some discs. Hey, what do you say? Hey, what do you say? Okay, I say we get a decimal point right here, Mr. War, okay? All right? How about a couple of them there? Just showing that whole line. In case I go down, I might want to choose a different one just for fun. Just a reminder. These are not full. These are partial. They're not a whole. They're wannabes, right? We say, hey, you're just a wannabe whole number. You just want to be a whole number. Yeah, just kidding. Where over here, they're already whole. They're complete. But we can join forces, like the tenths can get 10 of them together, right? And then he can move over into the ones column, which is like his lifelong dream. The tenths is just like, please, just I by myself, give me 9 more. We'll move into the ones column. It's like his dream. Eh? Okay. What? Oh, Mr. Warrior, you are really going off. I'm sorry. Okay, focus. So now we have 900s, but we don't even have hundreds on here. That's not very good, Mr. Warrior. How's that going to work? Well, we're going to have to do a lot of pretend in here. Okay, so here's another column. That's the tens place. Ooh, another column. That's the hundreds place. All right. So we're going to draw 9, and I'll do 4, and then I'll do, hey, this is kind of fun. It's like I'm just like, woo, 900s, okay? And then over here we have 500s. Okay, fair enough. I'll do 5 of those since I did the other ones like little dots. Hope you can see that. Now we have 500s, but we need to take away 3 of them. So we're going to take away those 3. Well, let's just cross them out. 1, 2, 3. Ooh, I missed them. Okay, I got him. Well, what does that leave us with? Well, it says it looks like we have 900 still because he was not affected. And then we have 200s. When we write that, we put 900. There aren't any tenths. I'm sorry, any tens. There aren't any ones. There aren't any tenths. However, there are 200s. We can always put it this way. In a vertical form, our algorithm showing 900 and 500 and 500s minus, look at 0, 0, 0, 0. I'm going to put a 0 here just for the decimal point. Makes it easier to see. Minus 300s, it says. I'm looking above. And of course, 5 minus 3 is 2. 0 minus 0, 2. Remember the decimal? That's right. Bring it on down. Bring it on downtown. Okay, just kidding. Okay, and then we have 900 here. And woohoo! Yay! Dun, 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 dun. Okay, I shouldn't do my victory dance yet. It's still early. There's many more problems to face. Okay, now we're slowly moving into looks like partial word, the written method here, with some numerical. That could be confusing. Okay, well, let's see here. Let's first look at our problem, 83 tenths. I could just draw 83 little disc in the tenths place. Why does that not sound too overly exciting right now? That could take me a real long time. So I don't think I'm going to do that. In fact, I think I'm going to steal this guy here, and then, I'm going to have some fun and make him really, really small. Like a little red. There you go. I declare you, little dot, to be infinite cloner. Thank you. Yay, thank you, buddy. Okay, so could you see doing like 83 of these? Actually, he's kind of small, isn't he? Let's fix that. Now I have my little red dot. Where did he come from? Whoa. Now I could do like 83 of these here. That's going to take way too much time. But remember we said that there were 10 tenths, right? In one whole? That's got me thinking. 10 tenths in one whole, so I could go 10, 20, 30, 40, 50. I could go up to 80, right? I'm just counting on my fingers. Well, there's 8 ones then. So 80, or I should say 8, not 80, 80 tenths is equal to 8 ones. You know what I'm going to do? That's right. I'm going to put 8 over here, and there's my 8. Now that counts 80, and that's only going to leave 3 more here. So 3 tenths. So that's 83 tenths, or 8 and 3 tenths. I like this. But I need another color. So let's change that. Yes, I have another dot. I declare you infinite cloner. Yes, okay. I have 6 and 4 tenths. Well, I could go ahead and put my 6 over here. So there's 6, and now I have 4 tenths. Very good. Problem, we have 83 tenths. We're taking away 6 and 4 tenths from 83 tenths. So I want to make sure what I'm taking away from. So you can see right here, we have a problem because I can't take 4 tenths away from 3 tenths. All right, because this is the blue. There you go. I changed the colors for you, so that way it makes it a bit easier so you can see what's being taken away. And here's 6, no problem. We could take 6 from 8. Not a problem, but here we have a problem, so what do? No fear, underdog is here. Okay, we could take one of these ones. Remember when the tenths, his lifelong dream was to turn himself into a ones? Well, now we could take one of these ones and we could convert it or rename it into tenths. And since this one red one here is equal to 10 tenths, that's what I could do. Now I'm going to draw a line showing that. So I'm going to take this one and I'm going to move him over here. How about like that? And I draw a little arrow. So he's coming over here. That automatically means that he's being converted. So I'm going to go ahead and then put 10 tenths over here. And there's another 5. So now I have 10. Whoa, we have all these tenths now. Now what we can do is go ahead and take the 4 from that. Well, here we go. So now we have our x. So this is what we could do. We could also make him an infinite cloner. Yes, you are. Okay, and now we're going to be taking away how many? 4 of them, right? So I could do this. I'm going to take away 4 of my red discs because 4 is being taken away from that 4 tenths from the, well, originally we had 3 tenths here, but now we have 13 because we added 10. So now that takes care of this. This is done. So maybe I can even do this maybe and then just show those 4 no longer exist. We're not going to count those any longer. A lot of little X's. You could just put a line through them. I got a little carried away. Mr. Dramatic had to. And that leaves now just 5, and then we have our 4, which leaves just 9 here. And then over here, we still need to take away 6. So let's go ahead and do that. So now I've taken 6 away, also making this not valid any longer. So we could go ahead and just do the same thing, put a big X. Okay, just letting us know those have already been used. We've taken them away. So it's like the blue, is trying to take away from the red, and that's basically what we had here in this problem. And now what do we have left? Well, it looks like we have 1, 1 that I see. So let's put that 1, 1 here. And that's just one hole, and then I have my decimal like listed here, and it looks like I have 9. So I have 1.9. Well, let's go ahead and do the algorithm. Let's see if that's true. We already determined that 83 tenths is the same as 8 and 3 tenths. So we'll write that 8 and 3 tenths as that. Okay, we're going to subtract 6 and 4 tenths. We subtract. Again, we have to regroup here because remember the same situation we had here. 4, you can't take 4 away from 3. So we're going to go ahead and let's go ahead and get one whole. And that one whole will turn into 10 tenths. So we'll put that 1 there, letting us that 10 tenths plus the 3 was 13. That's what we had over here. 13 minus 4 is 9. And remember the decimal point? That's right. Bring it on down. That's right. Bring it on down. We need to make sure that we bring that decimal straight on down. And then 7 minus 6 is 1. Oh, the beauty. It's such a lovely picture. You know what? I want to get my camera out and take a picture of this. Very emotional. Let's go on. Yes. Another problem with mixed. We have 9 and 2 tenths minus 6 ones, 4 tenths. Okay, and let's go ahead. Let's do this first. Let's do the algorithm first and see if it all matches up. So if we have 9 and 2 tenths, so here we're going to go ahead and lone 1. That leaves us with 8 over here now. Now the 10 tenths become 12 tenths because we added the 2 onto the 10 tenths. That's 8. Remember the decimal. Bring it on down. Yeah. Okay. That guy, where does that guy come from? Okay, 8 minus 6 is 2. So we're going to put 2 and 8 tenths. Let's see if that works out here. So we're going to show 9 ones over here. And I also have 2 tenths, so I need to get the 2 tenths here. And now I have over here, look at the blue, I have 6 ones. Sort of lined up. 6 ones, we have 4 tenths over here. Uno, dos, tres, cuatro. Hey, see, I can count to 4 in Spanish. Now I have 6 and 4 tenths. Okay, so again, this is takeaway. Now, remember when we did the algorithm, we did it in the opposite, we did it in reverse order. We did that first, and you notice we did have to regroup. And look at where that regrouping is. Here it is. That's the problem. That is the problem. What we need to do here is we need to take and convert one of these. So I'm going to just put a big X on him. And we're going to take that one whole and turn him into 10 tenths. First things first is we need to take 4 away because we have these 4 blue ones. So what we can do is take this guy here, and I'm going to take 1 away there. There's 2. Just for fun, I'm just take this one up here. This one here, it doesn't matter, any 4. So I have 4 here. And of course, then I'm going to do my big X just to remember that they've been taken away now. So I don't count them near the end. Those 4 taken away from those 4. And then over here, I have 6. They need to be taken away, and I do have 6, fortunately. And there's 6. And then to show that I took those away, the mega X. Okay, now this is what leaves us with the red, because the red was the one that was the number that was in front. So we have 2 here. We have 2 ones. Interestingly, we have 2 here. And then we have 1, 2, 3, 4, 5, 6, 7, 8. And we have 8 there. And you see it worked out. 2 ones and 8 tenths. Yes! Woohoo! Looks like we have 8 tenths. So I'm going to go ahead and put my 2. Maybe I'll just do 4 and 4. Now I'm going to do my 300ths and my 1,000ths. Okay, now blue's going to represent the number that I'm subtracting. I'm subtracting 292 thousandths from 831 thousandths. Yeah, we need to regroup here. We need to rename one of these hundreds and give that 100th into thousandths, which will be 10. Okay, now we need to make sure that we show how we renamed 100th into 10 thousandths. Now I can go ahead and subtract because I have 11 thousandths now. I only had 1 before, but with that 10. So now I can take 2 away. And then I'm showing I took the 2 from that 2. That's what I have left. Reason why I'm choosing to model it this way. Now I come over here, I have a same problem. I have 9 and I only have 2. I need to rename one of the tenths, give the hundredths 10 hundredths to help out. So let's do that. Okay, again, now I've renamed 1/10 into 10 hundredths over here, and now I can take these away. Okay, so I've crossed these 2 out here. So I had 9 of those blue, and so I took 9 here. I have just 1 left over here, and I just eliminated that so I know that I took those away as a reminder. And then I come over here and I can see it's no problem taking 2 tenths away from, looks like there's only 4, 5, 6, 7 tenths now. Now I'll go ahead and do this. Now those are gone. See how careful I was. That was the one regrouping, 3, 2 away. Should work out. We don't have any ones. But we do have 1, 2, 3, 4, 5 tenths. So I'm going to put that 5 here. And then I come over here. It looks like I just have 2. Oop, take that back. Erase. Delete. I have 3 actually. I noticed that 1 down there. And over here I have, looks like 5, 6, 7, 8. And 1 I have 9. So I have 539 thousandths. Well, let's see if that's for real. Because as I write my problem down, you can see that I need to regroup here. Oh, but he can't help out because he's in the same bind he is. So I'm going to go all the way over here to the tenths place, loan 1/10 to the hundredths place. So I'm going to give him 10 hundredths or 1/10. Now he's going to give 1/100th to the thousandths place. So now he has 10 thousandths. So now he'll have 11 since he already had 1 there. So 11 minus 2 is 9 last time I checked. 12 minus 9 is 3. And then 7 minus 2 is 5. I have my decimal point. Bring it on down. Straight on down. Okay, and then I have 0. Yes. It looks wonderful. Yeah. Now I think there's a lot of these problems here, and I think I've modeled enough of them, and I don't want this video to get too long. So what I'm going to do here is just model the algorithm, and you could always try these on your own. And this is interesting because we can make an equivalent decimal here so we don't get confused. So by putting a 0 in there does not change the value of the number. Now we can subtract, that's 3. Look, we need to regroup here and here, so we have to come all the way to the whole in the ones place. Take 1 whole, share that 1 whole into 10 tenths by giving it to the person in the tenths place. Now he can help out his neighbor, so he's going to give him 1/10. Now he only has 9 tenths left. Now he's just given him 10 hundredths, and now we're done. So 18 minus 9 is 9. Last time I checked. And then 9 minus 2 is 7. And then I have 3 minus 1, which is 2. I always check my work. Right back up to the top. 3, 18, carry the 1. That's 9, 10, carry the 1. Decimal. Bring it on down. Okay, 3, 4. There we go. 4 and 83 thousandths. And it worked out. Good way to check your work. And here you have 4 tenths over here. And in this problem, what you're going to have to end up doing is look at, there's 8 hundredths here, and there's 4 tenths here. But nothing's being taken away here, but the 4 tenths is, we're going to have to subtract from the ones. So the only way we can do this is by crossing out 1, 1 and putting 10 tenths here. Okay, there's going to be 10 of these. Now you can take the 4 away. 10 minus 4 is 6. But that's still a problem. We have 8. So now he's going to take that. What he's going to have to do is get this 6 and turn that into a 5 and give 10 hundredths to this guy. So now he has 8. That's going to leave 2. So we end up with 2, 5. Here's our decimal place that I didn't put in, and we have 5. 5 and 52 hundredths. Let's see if that's true. We'll write that right here. 6 minus, and look at here, we have 0.48. And I can see where this would give you problems because we don't have anything up here. Well, the rule is you can pick any whole number and you can write it as a decimal by simply putting in a decimal point and then putting zeros. In fact, this is actually called an equivalent decimal, and it is. Now you can see why we ran into problems because we didn't have anything there. Well, we go straight to the ones place. We get our 1 whole, bring it on over, giving it our 10 tenths. He's going to give 1/10 to him, giving him 10 hundredths. Now we have 2, now we have 5, and now we have 5, and that matches up. Okay. I kind of sped through this last problem because there were quite a few examples there. Now, incredible. What a lesson. You guys rock. I'm so grateful that you come here and you join me in this math video. Now, live long and prosper.